Hello dear all, I am Nilesh Kumar. Welcome you all in my lecture of algebra, where we are going to discuss about sum of first n terms of arithmetic progression. To understand the concept of arithmetic progression and the sum of arithmetic progression, we have to understand some of the concepts from our previous lessons, like definition of arithmetic progression, representation of arithmetic progression, and nth term of arithmetic progression that is represented by some word an or tn. So what objectives we are going to discuss today in our lecture? We are going to discuss about the sum of n terms of arithmetic progressions, the mean of arithmetic progressions, or generally known as arithmetic mean. Let us introduce Let us consider a situation in which Dishu puts rupees 100 into her money box, and when she was 1 year old, 150 on her second birthday, 200 on her third birthday, and will continue in the same order. So how much money will Dishu collect in money box by the time when she will be 21 years of old? Okay, so here the amount of money in rupees will be there. So put in the money box on the first day, on the first, second, third, fourth, and so on, and birthdays up to 21 birthday. So what will be the money, total money? To find the total amount in the money box on the 21st birthday, we will have to write each term up to 21 numbers. That means 21 terms we have to write again and again, and then we have to add them up. So don't you think that this is a very tedious task to add these number of terms? 21 number of terms we have to add, and this is a very tedious task. How can I go for? So to make it more easy, let us do one thing. So this is the sum is what? First year, first birthday 100 rupees, second birthday 50 rupees, and so on up to 21 birthday. This is the last term, that is going to be your 1100. And similarly I can reverse them. That means I can write in reverse order, so the sum will be remain the same. So I can say this is going to be 1000 plus 1050, and so on. This is going to be happening here. So 1100 plus 1050 plus so on up to 100. So adding these two to C will get some amount of money here. So this will be 2s will be equals to 1100 plus 100 plus 1050 plus 150, and so on. So in this way I can get s is equals to 21 multiplied by 1200 by 20. What is the 21 represents here? This 21 representing you the total number of terms actually. So how much C was going to happen after 21 years? So on her 21st birthday she was putting some amount of money, so this 21 represents the total number of years. So this is going to be calculated as 12600. The sum will be for her collection will be 12,600. So we will now use the sample technique to find the sum of n terms. So let us think. Your first term is a, and another term is a plus d, and then a plus 2d, then a plus 3d, and so on. So in the same way I can have the nth term of this ap will be going to be a plus n minus 1 into d. So what will be s? So s denote the sum of first n terms of the ap. So here we have s is equals to a plus d plus a plus 2d plus so on up to a plus n minus 1 into d. This will be your nth term. So if I am going to add these terms here, so what is happening? So it is going to be 2s is going to be c 2a plus n minus 1 into d plus 2a plus n minus 1 into d, and so on. There are many times of terms, so n terms are there. So these terms are repeated n times. So I can say that your S will be equal to n by 2 into 2a plus n minus 1 into d. So the sum of first n terms of an AP is given by n by 2 into 2a plus n minus 1 into d, where d is the common difference and a is the first term and n is the number of terms that you want to get. So we can also write these terms as, if you have s is equals to n by 2, I can split my 2a as a plus n minus 1 into d. A is your first term and a plus n minus 1 into d is your nth term. That means sum of n terms of an AP can also be represented by n by 2 into first term plus last term. Your last term is an. So now if there is only n terms, suppose there are only n terms in an AP, then an is equals to L. Let's say I am giving this a name here. I am just nomenclating here. So the last term is L. So I can have S is equals to n by 2 into A plus L. So the nth term of an AP is the difference of the sum of first n terms and the sum to first n minus 1 terms of it. So an is the nth term, that is represented as sn minus 1. You can understand this by using some concept by pictorial form also, and many more by using some numerical technique also. Let us discuss some example to solve arithmetic progression and the series. My question is, find the sum of first 22 terms of an AP. What is the sum of nth term of an AP? So Sn is going to be n by 2, 2a plus n minus 1 into d, where d is a common difference and a is your first term, and n means what? How many terms you want to get? So how many terms you want to get? 22. So n is equals to 22. A is your first term. So can you tell me what is the first term? First term is going to be 8 here. So your first term is going to be 8 here. You can put here 8. And what is D? D means common difference. That means second term minus first term. Same third term minus second term. That should be common. So that means common difference is going to be 3 minus 8, which is going to be minus 5 here. So I can write here minus 5. So I can put all the values of n, a and d respectively on their places. So S will be equals to 22 by 2 into 2 times of A is your 8 plus N is your 22 minus 1 into D is your minus 5. So I can put all the values and getting the result as sum of all the terms of AP that was given by 8, 3, minus 2 and so on will be equals to minus 979. So the sum of first 22 terms of the AP is minus 979. Let us discuss the second example. So my example is, what is the question here? Find the sum of first 13 terms of the AP. So same way you have to apply the same formula for the same here. So Sn will be equal to n by 2 into 2a plus n minus 1 into d, where n is your number of term that you want to find the addition of that part. A is your first term, d is your common difference. So A is your 24, D will be 21 minus 24, that is going to be minus 3, and N is your 13. That means you want to find the sum of first 13 terms. So the sum of n term can be obtained by putting all the values inside this formula. So here Sn will be equals to 13 into 12 by 2. So I can say that it is going to be 78. So the sum of first 13 terms of the AP given by 24, 21 and 18 and so on is equals to 78. Let's have some more good examples, like in bank or in other places where the mathematics works in a very good manner and in a very big application. The income of a person is 3 lakh rupees in first year, and he receives an increment in his salary of 10,000 to his income per year and for the next 19 years. So what will the total amount of money he received in 20 years? So that means your n is going to be 20, and he has its first salary of first year is what, 3 lakh rupees, and he has an increment of 10,000 rupees every year. So after 20 years, how much money he get in all? So as 20 is going to be n by 2 into 2a plus n minus 1 into d. So I can put all the values here. So n by 2, n is your 20, a is your 3 lakh, multiply by 2 is going to be 6 lakh, plus n minus 1, n is what, n is your 20, 20 minus 1 is 19, so I am writing here 19 into d. D is your the increment part, every year the increment part, so it is going to be 10,000. So I can say 10 multiplied by this concept, so it is going to be 79 lakh rupees he received after 20 years. Let us discuss about arithmetic mean of an arithmetic progression. Given two numbers a and b, so we can insert a number m between them so that a m b is an AP. Okay, such a number m is called arithmetic mean. So suppose a and b are the numbers. So in that case, note that m minus a and b minus m will be always equal. That means I can say that from this expression I can have the value m is equal to the first term and the last term by 2. That means a plus b by 2. So we may also interpret that arithmetic mean of two terms a and b as their average, that is a plus b by 2. More generally, given any two numbers a and b, we can insert as many numbers as we like between them such that resulting terms are in AP. Let m1, m2 and so on mn be n number of terms between a and b such that a, m1, m2, so on mn, b are in AP. Then here b is the n plus 2th term. You can say here, what is n plus 2th term? You can see first term is a, of course. So m1 to mn, how many terms will be there? This will be your n terms. Total how many terms up to n mn, how many terms are there? So a is also included. So n plus 1 terms will be there up to mn, and b is your n plus 2th term. That means total number of n plus 2 terms will be there. So b is equals to a plus n plus 2 minus 1 into d, where a is your first term, d is your common difference. So from here, this concept, you can get the value of d. D will be your common difference. So you can get the value of d in term of a, b and n. So in this case, thus the numbers between a and b are as follows. So m1 will be equal to a plus d, that means I can put the value of d here. Again m2 is equals to a plus 2d, again I can put the value of d here, and mn and so on, I can put the value of d again here. So in this way I can get each and every value from each and every mean, that is m1, m2, m3. That means I can easily form an arithmetic progression with the help of arithmetic mean. Let's have some example here. Insert 6 numbers between 3 and 24 such that resultant sequence is in AP. So if I want to insert 6 numbers, that means let's say m1, m2, m3, m4 and mn, that is m5 and m6. I want to insert these 6 numbers. So how can I insert this? So 3 and 24. So between 3 and 24 I am inserting m1, m2, m3, m4, m5 and m6 are in AP. So in this way, what is the first term? First term is 3 here. B is equals to 24. That means your last term is 24. And how many total terms are there? So you are inserting 6 terms now. So 6 terms are these all are 6 terms. And first term and the last term is going to be 1 plus 1, that is going to be 6 plus 1 plus 1, that is going to be 8. So total number of terms are 8. So you can have, what is the first term? A is your 3, that means you already get the value of A. and your last term. What is the last term? Eighth term. That means M8 is your last term. So that means M8 is your 24. So I can say that M8 can be represented by A plus 7D. So from here I can get this thing. That means A plus 7D means what? A plus A is your 3 plus 8 minus 1 into D is equals to 24. 24 is your last term. So from here I can get the value of D here. Okay, so that means D is equals to 3 by calculating this result. So since you know that M1 is your second term, that is represented by A plus D. So it is going to be 3 plus 3 here, which is 6. Similarly, for second term is going to be A plus 2D. That is A plus 2D means what? I can put the value of A also and I can put the value of D also. So A means your 3 and D means again 3. So 3 plus 2 times of 3 is going to be 9 here. That means 6 plus 3. Okay, M3. M3 means I can say here M3. M3 means what? Your fourth term. You can see first, second, third, fourth. M3 is the fourth term. So it is going to be A plus 3D. I can put again the value of A and D and so on. For each and every term you can put the values. So since 6 numbers between 3 and 4 are 6, 9, 12, 15, 18 and 21. Here are some problems that you have to go for your practice to understand the arithmetic progressions, the sum of arithmetic progressions and arithmetic mean more efficiently and in a good manner. So my first question is, find the sum of first n positive integers. Find the sum of first 24 terms of the list of numbers whose n terms are given by an is equals to 3 plus 2n. You can take here what? N is equals to 1. So a plus 2. Similarly n is equals to 2. Put here 2 and then again 3, 3 and so on. And you can apply here a formula for S24. That will be equal to 2 times of a plus 24 minus 1 into d. That is d is your common difference. Sum of first P, Q and R terms of an AP are A, B and C respectively. Then prove that this thing. Hope you are able to practice this thing. Insert 5 numbers between 8 and 26 such that resulting sequence is in AP. So hope you have enjoyed today's lecture. So, thanks for joining my lecture here.